Send PRs to Gunnar's projects, you'll get a job. That's what I'm hearing.
That sounds good, yeah. It's the first AI-based project I'm doing, and it's AI first, I would say.
Hey, Tim Berglund here. Welcome to another episode of the Confluent Developer podcast. Today, I spoke to returning guest Gunnar Morling about Hardwood, his new Java-based Parquet parser. Gunnar has applied some of what he learned in his famous 2023 viral hit, the 1 billion row challenge. I'll put a link to that in the show notes if you don't remember it. It's pretty cool. And he's combined that, his extensive experience as an open source developer and project leader, to build a next-generation reader and writer of Parquet files. That's what Hardwood is. And in this episode, of course, we talk about how AI-augmented engineering has played into the project and kind of how he's using AI. And I think we just generally give the thing a pretty solid deep dive. I really enjoyed this conversation. Always love talking to Gunnar, and I hope you love listening in. Hey, Gunnar, how you doing?
Hey, Tim. I'm pretty good. How are you, man?
I'm doing all right. It's good to have you back. We are talking about your new woodworking hobby, as I understand today.
Right, yes.
And you want to talk about Hardwood. I was confused. But now, you've been working hard on this project called Hardwood. I've seen a lot of conversation about it. Maybe that's mostly from you. Maybe it's for other people. I don't know. But I thought this is really important, and I wanted to get it on the show. So what is Hardwood?
Right, yeah, awesome. I mean, first of all, thank you so much for having me again and, taking the time to talk about this project. Yes, I went into the flooring business, and I'm dealing with hardwood and Parquet.
My wife and I are building a house, so this is all very interesting.
Maybe we can, find an agreement there.
Right.
No, the idea is, it's a new parser, a reader, and hopefully also writer for what's called Apache Parquet. And Apache Parquet is a columnar file format, and we can talk about what that means. And yes, Hardwood helps you to parse and also soon write those Parquet files. And I thought I would be smart, and the project is named, it's like a play on words, so it is file format Apache Parquet. I thought Hardwood, it's another kind of flooring, and that's where the name is coming from. But it's terrible in terms of search engine results, because if you search for Parquet and Hardwood, it's really bad.
Exactly. I'm an expert at that kind of thing. Like, oh, this name is so clever. I'm so happy with myself. You can't search for it. So
yes, exactly right.
So obvious question, Parquet, and maybe we'll throw a link in the show notes. Like if you don't, you said it's column or file format. If you don't know what Parquet is, we'll give you a link. You should read up on it. But it's not like there weren't any APIs. I mean, it's the kind of thing where pick your language, there's a language binding. There certainly was a Java one. So
absolutely.
Why did you do this?
Right. I would say 2.5 reasons for doing that. So yes, first of all, there is a very well-established library for Parquet in Java, which is called Parquet Java. So, people have been using this for a long time, and it has been around for a long time. And this is part of the reasons why I thought there is, the need for something new, because it comes with quite a bit of dependency baggage. So essentially, if you pull in Parquet Java, you pull in the entire Hadoop stack. This is just, because of where it's coming from. And now you want to parse a Parquet file, and you don't want to have like a gazillion of, transitive dependencies jars on your class path just to do so, right? So it's a nightmare in terms of just supply chain security, right? It's a lot on our minds these days. You just don't want to have all this overhead of all those dependencies. So that's the one thing. First reason. Then this existing library is single-threaded, and today, of course, all our machines, they have like many cores. My laptop, 16 cores. I guess everybody has those beefy machines these days, and we want to make use of those CPU resources, right? We don't want to just parse a file with one core and let all those other 15 cores sit idle. So that's the second reason. And I said it's like 2.5. There's also is an angle. I wanted to see how far I can get using those LLM tools like Cloud Code and so on for building such a relatively low-level code base. So this also was, just for me a little bit, okay, how good are those tools? Are they fit for purpose for this particular application? And this is, also like kind of like very selfishly a theme for me.
Yeah, okay. And I since you started this, I have kind of felt echoes of the billion row challenge. I mean, it's not exactly the same, but
right.
Did that experience inform you here?
Absolutely. I mean, there was this idea, yes, let's put some of those learnings from the 1 billion row challenge into practical use. And, let's see what we, can make with those findings and insights. And can we build an actual, hopefully production-worthy project based on those insights? Absolutely.
Yeah. I'm super interested in the multi-threadedness. Maybe we can come back to that later because that seems difficult to pull off. But first, the zero dependency thing. First of all, John Donne would like a word with you. He's the poet who wrote "No Man is an Island, entire of itself," and you're like, "No, actually, I am." Pulling in a bunch of dependencies. If you build stuff in Java, if you build stuff in JavaScript or TypeScript, that's just life, right? You have a dependency, and here's 600,000 other things it needs. And you made a point about the supply chain aspect there. So, what? Tell me more about that, and what do you feel like the trade-offs were? What did you lose in doing
Absolutely. This? Yes, I mean, it's a really multifaceted question there. But so why is it a problem? I mean, just having all those dependencies, yes, so there's this security aspect, right? So there could be CVEs in any one of them. You need to make sure you're on the latest versions. Then maybe you just cannot simply upgrade one dependency, one transitive dependency. It could, cause version conflicts. So there's that. Then there is just the question of what's the footprint on your class path? And do you even need to load so many classes to do a certain thing? So there's all that. But yes, of course, also libraries give us something, right? It's not like we just randomly pull in stuff for the sake of it, right? So we want to benefit from that functionality. And I think this is where the agentic coding tools, they definitely change that consideration quite a bit. Because, with those tools, I think you just can self-maintain much more code. So let me give you one specific example. So, oftentimes those Parquet files, they are stored on object storage. So you have a file, it's stored on S3, and now instead of downloading the entire file to get something out of it, you can apply all kinds of neat tricks and statistics and so on to only touch on specific chunks from the file, and so this reduces the I/O quite a bit, right? So you only need to download specific sections of the file you're interested in. Now, typically you would do that using the S3 SDK from Amazon, which by itself is quite dependency heavy, actually. And now here, what I'm doing is, Java, since version 11, it has a built-in HTTP client. This is totally good enough for that. I can do those range requests, that's fine. But now there's one subtlety. If you want to do those HTTP requests against the AWS API, you need to sign those requests with a specific AWS defined signing algorithm. Now, typically, this is something which I would not have rebuilt myself traditionally, because it's easy to get wrong, and the S3 SDK would do this for you out of the box. But as it turns out, this signing algorithm, it has a very well-defined spec and also a test kit. So you really, with an LLM, you kind of can one-shot this signing algorithm, and then you have it by yourself, and you don't need to bear any dependencies. So that definitely, changes those, let's say, make or buy decisions.
The agentic augmented coding,
yes,
whatever we want to call it. Yeah. That is a very good point. There are things that it seems cheaper to just rebuild.
Right.
And
absolutely.
It is,
and of course, but then you want to also draw a line, right? So, I mean, you have been using this stuff a lot, right? So you will know there's a gazillion of different ways in how you can actually authenticate against AWS. It could be with just your, essentially user ID and secret ID. But it also could be an IAM role, a role attached to your EC2 instance and so on. And I felt this is not something I want to rebuild, because it's just so open-ended, and AWS, they could change this at any time. So there, actually, I am falling back to something which they provide, but you can be much more conscious and more meaningful in terms of making that decision.
Is that the hardwood AWS auth module? That's the optional module?
Yes, exactly right. So, if you want to, let's say you want to use IAM identities, then you could pull in this optional module for this particular
Got it. Because doing that in a zero dependency way, in your judgment, was just over the line. You had to make a judgment call there.
Exactly right.
Okay.
So it's not black or white, right? So it's about trade-offs.
Yeah, this is a super interesting Super interesting thing to do. I'm guessing that you're learning a lot about when to make that call. It's sort of we're using the word taste a lot, but it's almost a taste kind of thing. Like,
Right.
I just feel like this would just be stupid to rebuild this, and so we'll take on a dependency, but defaulting to not taking on dependencies.
Exactly. That's kind of exactly right. That's the mental model. Let's default to not. But then another example is Parquet files. They support all kinds of different compression algorithms. And again, they felt there's just no point in like reinventing the wheel and like re-implementing like gzip and all those different ways for compressing and decompressing files. So again, this is like an optional dependency. So you would pull in just those compression dependencies of the files you actually have.
So if the file is using compression, then you have a dependency to decompress.
Exactly right.
Okay. So nice. And it's not a thing. It's kind of a closure thing, is how I think of it. I'm not going to have any dependencies. It's just going to be a library. It's just not a thing I see in the Java community a lot. So I appreciate your experiment here. I think.
I think it should be more common, to be honest. One of my shower thoughts is this entire thing where we automatically pull in transitive dependencies. Maybe we would be better off if that were not the case. So if you pull in a library, and instead this one also then pulling in like 3 other libraries, and those 3 they pull in like 9 other libraries, whatever it is, right? So if we were not to do that, we had to be much more conscious. I think that would be better, maybe.
You were. Do you feel like you were a little late to the game or a little conservative in agentic development? Is this your first big project doing that? Talk about your journey there a little bit.
Right. I guess I feel like we all are learning. I certainly feel personally I am pretty much at the beginning of all that. But yes, it's the first like really heavy AI-based project I'm doing. And, it's AI first, I would say. So 95% of the code is written by AI. But then I make a very strong point about like reviewing everything, and we can talk about the nuances there. So, the tagline I have mentally is like it's built with AI, not built by AI. So I want to use those tools, and I want to be better in terms of using them for code review and all those kind of things. But I don't want to, give away the key to the kingdom just yet, and just send it off. Hey, build a Parquet parser, because I just don't see how this would work at this point.
Right. Yeah, the models are not. I think the reality of we're recording this in the middle of May 2026. The models are incredible. The models are not fire and forget super intelligences that just go and build computer programs for us based on big prompts.
My Claude.md file where you encode all those rules and specific guidelines, it keeps like growing and growing. So I add more and more instructions to it. It doesn't really care by default a lot, for instance, about maintainability. So you have, you need to wrap words, maybe, if like a UI dialog and you need to wrap words. So it will happily have this code for word wrapping in like 3 different places, unless you tell it, don't do that. Try to extract something and try to unify it. It doesn't really care about what is a public API and what is like implementation specific. So how can we, keep those things apart? So there's all those kinds of nuances where you say taste, so you need to have that, and you need to tell it about all those conventions which you want to enforce.
Yeah. I think in some cases, in any given processing of a prompt or a spec or whatever tools you're using, it may not be aware that there are 2 other implementations. It's creating one because that's just not in context right now.
Exactly.
And for us, we have the benefit of a big associative memory where you see something and you go, even if you weren't thinking about it, you go, oh yeah, that's right, I know that. You and I can be reminded.
Or you just have that feeling. It cannot be like I'm the first one in this project who has to do this word wrapping, right? Something must exist already. You kind of have like this intuition. What would be the odds? Exactly.
Right. So, but hey, they're amazing tools. That's certainly my experience.
Absolutely. And, right now I'm working on my flow for code reviews because people send large PRs and I want to be on top of them, of course. And so, I have what they call like a custom skill for, how I want to do code reviews. And again, the core idea is I always want to be like a human in the loop, right? So the idea is, okay, if I ask the agent to do a code review, then it will write it down into like a markdown file, which has like the actionable items with like checkboxes. And then, for instance, I have another skill where I then can say, okay, please, work through those findings and check off those boxes. Or maybe if there's like a decision to be made, there's like an open question, should we do A or B, then surface this question. And I felt this works actually pretty well to kind of formalize how I like to think about code reviews.
Okay. So you are getting external contributions. That's wonderful.
Yes, absolutely. So there's, as it always is, there's a few people who do a lot. Actually, one of them we hired just into Confluent. Very excited about it. Hey, Ryan. There's other people, maybe they do like a thing or two and then they go away. But so far, I think like 16 people or so have contributed. So yes, it's nicely ramping up.
All right. See, send PRs to Gunnar's projects, you'll get a job. That's what I'm hearing.
That sounds good, yeah.
Now, a quick word from our sponsor. Confluent Developer, the podcast, is brought to you by Confluent Developer, the website, which has everything you need as a developer of data streaming systems. And it's completely free. We've got curriculum, hands-on exercises, executable tutorials, the online data streaming engineer certification, also free, a way to find a meetup near you, those are free. Everything is there. I really want you to be successful in your journey as a data streaming engineer, and this is the site that has what you need. Check it out at developer.confluent.io. That's developer.confluent.io. Now back to the show. I want to get back to the your parallelizing of ingest. Now, I know enough about Parquet to kind of imagine how that works, but talk to me about that. Like, my guess is that the obvious first approach may or may not work. So what? Tell me what the obvious approach to parsing Parquet in a multi-threaded way is, and where you ended up. If it's not that.
Okay, so maybe we need to set the scene a little bit and talk just a little bit about the structure of those Parquet files. So, as I mentioned, it's a columnar file, right? So, unlike a row-based file, like let's say like CSV, which has like, for each record a line or a row in the file. Here, we store all the values of one column consecutively, right? So let's say you have customer data and you would have like all the names of your customers, like one after the other, then all the birth dates and so on. Why are we doing this? Well, first of all, it tends to compress very well. So, you could, for instance, do things like delta encoding. If you have like timestamps and they are like ordered, you could just store, instead of storing each timestamp, you could just store like the difference between two of them, right? And it would be much smaller. So it can be stored very efficiently. And also, if we think about like analytical use cases, oftentimes you want to aggregate all the values or filter all the values from one column, right? So now if all those names or all those ages or whatever are like written consecutively, we can just take that one column, process it, project it. It's very efficient for analytical workloads, right? So that's the background. Now, how would you parallelize it? I mean, you could think about it. Well, I could parallelize at the column level, right? So I could have, for instance, two threads, and one processes the name column, one processes the age column, and this works.
That's the approach that came to mind, right? When you said multi-threaded, I'm like, oh, that's cool. I guess you would just have a thread per column.
Right.
And I sense a trap, so.
Right, yes, there's a trap. I mean, it's how I started. It's a very quick win. Yeah. It is a tangible improvement over single-threaded, but also it hits a limit pretty quickly. Because the thing is, maybe you just don't have that many columns to begin with. So you have those 16 cores, but maybe your file just has like 8 columns, or maybe you're just interested in 2 columns, right? So it just is, not fine-grained enough in terms of parallelism. So that's one problem. But the other problem is that also different columns, depending on the type, the data type, and also depending on the compression and depending on the encoding, they are more or less CPU intensive to decompress. Right. So it just, if you want to read 1,000 values from one column, depending on all those things, it might take twice as long to do it for that one column in comparison to another column. Which means if you parallelize just at the column level, essentially, one thread would be done and it would just sit idle and wait for the slow column to finish. So that's also a problem, right? And what I'm doing here is I'm going one level further down. And the thing is, those columns, again, they store the data in what's called pages. So, a page essentially is like a self-contained block of data. And now this is the level of parallelism I apply. Now, let's say, I have two columns, and one of them maybe has like 20 pages, and the other one has maybe like 2 pages. Then I can assign essentially more threads to that column with the many pages, or maybe with those pages which are slow to process, and give less resources to that faster column. And that's essentially the core idea which I'm applying.
And pages are an inherent part of the Parquet format. So
exactly right. Yes.
Okay.
Exactly.
So you just pull in a bunch of pages and divvy them up to threads and let the threads keep the threads busy. As many threads as
exactly. That's the on a very high level the idea. Then there is this notion of what's called predicate pushdown. So you want to query those files, and now you don't want to load all the data and just then to discard the chunk of data you're not interested in, right? So let's say you're just interested in customers, who live in this. We have a specific zip code for the sake of the example. And now what Parquet files also can have, they can have statistics. So this Parquet file will tell you very efficiently which of my pages actually have data in that zip range I'm looking for. And now if you think about like remote files on S3, if I don't have to download those files, which I'm not even interested in because I know they only contain zip codes I don't care about, then of course things are much more efficient. And again, like all this predicate push down, and then also like filtering the remaining records, all this is happening in a multi-threaded way.
So Hardwood is aware of the predicates in the query, or potentially aware of the predicates in the query.
Exactly right. So there is a simple a query API. So it supports projections, it supports all kinds of like filtering, less than, greater than, equals, and so on. Logical like and or groupings. And now, if you were to build like a SQL parser on top of that, or a SQL query engine, you could employ that predicate pushdown capability to do exactly that.
Okay. And of course, there's already any number of such query engines that'll run queries on Parquet. And Hardwood presents itself as now a more efficient way to access the underlying Parquet files.
Exactly right. So that's definitely one of the goals I would have. Once dust has settled a little bit, we have maybe done like a stable release. We also have write support. So currently we only have read support, but let's say once we have write support, then it would be very interesting to see, okay, what would it take to integrate this into Flink? And I did some explorations already with the Flink Parquet modules, because then again they would benefit from zero dependencies and so on, right? So I think it's a very interesting proposition.
Are there any more parallelism wins that you can see that are on the horizon now that you've got pages figured out? That seems optimized, but what's remaining there?
Right. I mean, there is of course this entire notion of SIMD instructions, a single instruction, multiple data. So it's CPU instructions which essentially work on multiple values all at once. So let's say. Again, you want to filter data. You're only interested in specific, customers who are older than 18. Now, instead of looking at each age value one by one, with such a SIMD instruction, the CPU will actually be able to look at 8 values or 16 values or maybe 32 values all at once and essentially give you this data at a very fast pace. And this is something which, Java... not really supports at the moment. There's what they call.
That was my next question.
API.
How do you make Java do this?
Right. So they have what they call an incubating API, which gives you that SIMD capability. But I really hope it's going to be stable at some point, and that we really can rely on that and utilize it.
It'd be nice if the JIT just figured that out and just did it.
Right. And it does that. So yes, that's a very good point. So there is what's called auto-vectorization. So there's a Java hotspot engine, and the compiler is actually very smart. So if it detects certain looping patterns, it will sometimes auto-vectorize the code and actually execute it into, a SIMD code. But it's kind of brittle, so it's very easy, for instance, to mess this up. So let's say you have this code, and then by means of looking at the actual machine code, you have figured out, okay, this gets auto-vectorized, and you feel very happy. Then maybe next day your LLM comes along and it changes just a little bit of that code, and then for whatever reason the compiler cannot auto-vectorize it any longer. So it's tricky to rely on that.
Got it. So it'll be an annotation or something like that.
Big comment. Don't mess with this code. Leave it as is.
Yeah.
It's written in a very specific way for a very specific reason.
Well, I'm sure we should direct a tweet at Brian Getz and say, this would be so easy if you would just make this one change. It would fix everything. I know he
loves those. He loves those comments. He loves those.
Yeah. It's so easzy. Just do this.
Have you ever thought of doing that, Brian? Yes. And
right. Yeah. Well, you know what? Yes. That is his answer. Nice. Okay, that's exciting.
Absolutely.
Okay, so this is fundamentally an API, not your first rodeo there, but what are you learning there? I mean, like there's a choice between sort of row and column. I know it's columnar format, but you can still expose a row API because that's how a lot of people think. So, what's your thinking there?
Right. I mean, we actually do have both. So we have what we call a row reader API and a column reader API. So yes, because many times data, you want to reason about it in terms of rows, and actually Parquet also supports nesting, and you can have like a record which has a list of lists or a list of structs and so on. So it can be like, really like, let's say JSON mentally, like deeply nested data. And this, can be expressed nicely in a row-based fashion. So we have that, but there's also a price to pay to assemble that representation. And for use cases where you just want to crank through the numbers and do this analytic workload, then we have this columnar API, which essentially gives you batches of the actual values. So like you get like an array of doubles, or you get an array of ints, and then you can process them.
Not boxed. Those are primitives.
Absolutely, yes. So that's actually also another thing. There's this project in Java, what they call Valhalla, which is about what they call value types. And at some point, it would allow you to have like generic code which operates on primitive data types. We don't have that yet. So at this point in time, we actually have to duplicate quite a bit of code because we want to have like execution flow which is optimized for int arrays and for double arrays and so on. And we don't want to box this into array lists of integer because it would be like very slow.
Yeah, and that's not. If anybody knows you, it's just not how you do things.
Right, and that's one of the goals, to be like real fast. We also want to set up like a regression detection in terms of performance regression. So if I do a silly change, or my LLM does a silly change, and it causes a slowdown, we want to be able to figure this out. Right now, it's a bit more manual, and we have a few tests which you have to think about to run after changes which may be perf impacting or not. But yeah, if this was automated, that would be much nicer, of course.
Yeah. And on the topic of the API, I think you recently reworked the reader. Well, there's not a writer API yet, so yes, it's the only API into being a builder.
Right.
And so aesthetically, I'm a fan. I'm never going to complain. But what do you feel like you got wrong in the first pass there?
Yeah, I mean, so the thing is, if you build this reader, more and more options we added to that. So first of all, it was just about, okay, give me a specific set of columns, so like a projection in terms of query languages, right? Then later on, we added this notion of predicate pushdown. So we had like an overload of that get me a query builder, get me a row reader method, which takes like this filter expression. Then we added the capability, I want to have just a certain number of rows. I only want to have like 10 rows or 100 rows because we also actually have this interactive CLI tool which lets you take a look at your Parquet files. And for that, you want to have just like a window of data, also maybe with the starting offset. So long story short, we added more and more options, and then we had like 5 or 7 or even more like overloaded methods to get a query like a row reader. And at that point, we decided, okay, let's go back to the drawing board and let's have this builder and make it a more, a pleasant experience to, provide those options in a safe way, and also like in an intuitive way, right? Instead of having like all those different methods with all kinds of different parameters, and it's just hard to figure out which one you want to call.
Yeah, that makes sense.
And we are still like pre 1.0, so we take kind of the liberty not to nilly-willy change stuff, but if there is like a meaningful improvement, or we figure out we have like cornered ourselves, then we just take the liberty to break.
Yeah. No, you're in the process of exploring the space right now, so that's you have that right. Not again irresponsibly, but you don't know what it's supposed to be until you build it.
Exactly right, and we want to move fast, right? So we also don't want to like iterate for 4 weeks upfront and then ship something. We want to, be like really lean and mean and get something out, and then
that's what I've seen. I mean, honestly, that just kind of as a somewhat outsider to the project, it really looks that way. It looks like he's going to have this thing built in 9 months, and it's going to be pretty much complete, and incremental improvements after that. I mean, it just, I could be wrong, but you've done this kind of thing before. And it looks like it's going real well.
Yeah, thank you so much. I mean, that's the idea. There's also like, again, like amazing people who are working with me, and, they add to the pace. But actually just today, I had a very interesting conversation with somebody who also contributes to the project, but not a lot. More like, things here and there. And so he actually said, I have a hard time to follow along because like you guys, are working with such a high pace and stuff changes and you rework the architecture, and it's a hard time to follow along. And I felt actually it's a very serious point, because with those LLM tools you are just so fast and you can ship this 5,000 lines of code change, which is a meaningful improvement. But if you have those like every second day, it's really hard for people who are not like every day involved to follow along and stay in the loop. Absolutely.
You mentioned AI again, and I can't help myself. What's the worst thing AI has done in the project so far?
Oh man, I don't know. Sometimes I'm wondering whether it's me or whatever, but I've had like really funny things. So, there's this thing. I mean, it's trained on human artifacts, right? And sometimes it just shines. So, for instance, what it initially did is sometimes it would just not fix certain failing tests. It would say, okay, I'm doing this change and I see this test is failing over there. It's not my department. It literally told me that, not my department at some point. And, I just live with that. And then I literally added a rule to my Claude.md file. That's not how we want to do it. If we see something which is broken, then we got to fix it. Also, if it's not our current work, which may have been causing this. At one point, I was iterating with Claude on some design or whatever. And then it said, after a while, okay, I feel we have reached a good point. Let's call it a day. Now I was like, dude, no. Now I also just want to build it, so don't hang up on me.
What I identify with Claude there on the those tests, they're okay.
Exactly.
I'm fine. I don't really want to. I'm not into it.
Yeah, I mean, I guess it's just a human. But then also there's the thing. So sometimes you do like this involved design, and then it says, okay, this is gonna take like 2 weeks to build. Then you say, okay, Claude, go and build it. Like then 10 minutes later, it comes back. Okay, I'm done. Like you always wonder, okay, where are like those super weird estimates coming from?
Right. And do you reserve tests for humans to write, or do you have Claude write tests based on specs you give it?
Yes, so it's mostly written by Claude, and actually that's also one of the reasons why I think this kind of project, it really lends itself very well towards agentic coding, because actually the Parquet project and the upstream community, they provide a very, very comprehensive suite of test files, so which expose all the different encodings and types and compression algorithms and variant and so on. And so you just can implement like really meaningful test coverage by essentially using those files, and then I just compare the output which hardware gives to the output of the upstream Parquet project, and if there's a difference, well then obviously probably it's on us to fix it. And this worked really well. So initially, until we had like the full coverage of that, you could just tell, okay, now look at this test file and make it work, and it would go and then implement like the changes in the engine.
A few more questions. We're getting close to time, but I can't help myself.
Sure.
There's a few things I want to know still. I mean, this has been a fair amount of work, it seems like, even with agent-augmented code. So
Absolutely.
What's the lesson here for the people who say, well, like SAS is dead. There's no moat. We can just vibe code whatever we want. You're heavily relying on agentic development,
Right.
and yet this is a months-long project with an interesting roadmap ahead of it. So just talk about moat and AI, and with respect to this or any project, what do you think?
Absolutely. Yeah, I don't know. I mean, personally, first of all, I think I also underestimated the effort it would take. So initially, I thought, I don't know, maybe by this point in time, I started, around December, January, and maybe by this point in time, May, we are already further ahead. But yes, I mean, as it turns out, this file format, it has just a very long tail of, different capabilities. There's things like Bloom filters, which we don't even support yet. There's encryption and so on. So there's just a long tail of stuff you just need to work through. So there's that. It just is a large surface. But then also, I think without supervision, it just wouldn't get those things right. Like, what's a clean and well-defined API? What is a consistent API? And we don't do similar things very differently in different ways in the code base and in the API. How do we keep this maintainable? So I think it's very important to have somebody in the loop who is on top of that, and who then also codifies all the things in skills, CloudMD, and so on. But yeah, also it's just a lot of stuff to get right and to make it efficient. So I mean, yes, you could say, okay, I want to have a Parquet reader for those particular files which I have, and you could point Claude and it would give you something pretty quickly. But you have a comprehensive engine which really supports that long tail of features, which is efficient, which is maintainable. It's a lot of work, and I don't see at any point soon that you would say, Claude, build me that, and it would give you that what we have done now in multiple months with multiple people in a half a day or what.
Yeah. Do you recommend it for prime time yet? Again, this is the date is important. It's May 11th, 2000, and I think it's the 11th, 2026. So who should use it? Who should not use it?
You mean Hardwood, right? Yes.
Hardwood. Did I say Parquet? No.
No,
Parquet,
I wasn't sure.
For the record, it's probably really safe to adopt Parquet. It's fine. Go ahead.
I thought
you don't want to rush into these things, but sorry.
I thought you might refer to the LM-based coding tools.
Oh, right. No, also agentic development. Let's do it, please. Get it.
Right.
Get on board. Hardwood.
Right. Yes. I mean,
podcast, is it ready for prime time?
Right. I would say, people should probably wait for 1.0 to put it into Anger for their reading use cases. But I mean, by now, I think it's pretty stable. Definitely efficient. So I would love for people to give it a try and parse their files and use it. And if they run into any kinds of problems, report back. That would be great, right? What I also realize, for people to really adopt it, they want to have write support, right? I mean, let's say we wanted to integrate this into a Flink. As long as we only support reads, it's just not a good proposition, right? Because then they would actually have two dependencies, even more, Hardwood for reading and the existing one for writing. So that's not very attractive, right? So we need to have write support. That's on the roadmap for 1.1. And then, I would hope people will adopt it quickly. We also have a compatibility layer. So essentially, we kind of re-implement the existing Parquet Java APIs on top of Hardwood, so that it's kind of like a drop-in replacement. I think I feel pretty good about it.
Good. Wow. Okay, that is awesome. Benchmarking. Are you afraid of embarrassing Parquet Java, so you don't want to run benchmarks against it? Are you afraid of embarrassing yourself?
Yeah. No, I mean, neither. So the thing is, there's this entire notion of benchmarketing, right? And or what they call
liars, damned liars, statistics, benchmarks. That's Mark Twain gave us those four.
Yes, exactly right. So there's all that. So I want to be very, conscious and cautious about whatever numbers we publish. And the worst thing I think which could happen is you publish a benchmark, and let's say we show Parquet Java does X and we do Y. And we say, hey, we are much better. And then somebody says, oh, yeah, this is because you have hold it wrong, and you should have done, whatever option or knob in Parquet Java, and this would have been much better. So, actually, this comes back to what I call the benchmark paradox, because the thing is, if you want to compare different tools, typically you don't have the deep insight into every one of them to tune it well and use it perfectly well. So there's a challenge. On the other hand, if you do have that level of insight for one of the tools, then maybe you don't want to compare it in a benchmark where another tool would win. So there's a bit of a problem there. But ideally, yes, we get some numbers and we would run it by the Parquet community, and we would invite people to contribute and validate. So that's the idea.
Yeah. Okay. So you are. This is open source, right? It's and
yes,
you work for Confluent. Is this a Confluent thing? Is it a you thing? Is it what? How do people think about it in that way?
It's a good question. It's not an official Confluent project at this point in time. I mean, I've been working on it on my Confluent time, but it's not. Not like Confluent supported or whatever. I don't know. Maybe at some point it would be. Would be great. But yeah,
at least they'll use it. Tableflow.
Right, exactly right. So I mean, Tableflow. Actually, I spoke to those. Now that you say this, I think it would be very interesting for them to integrate this into Tableflow and make use of that engine.
Cool. Last question. Most interesting thing you've learned about Parquet, not just the JVM, but about Parquet, that most surprising, interesting thing in the process so far?
About Parquet, let me see. I think, really, just that fact that it is this massive thing which has grown over a long time, and it gets, more and more capabilities. So I completely did not expect this. So, for instance, just recently we added what's called support for variant. So that's like a self-descriptive type, which kind of, takes. It's a bit like JSON mentally. It can be like arbitrarily structured, and you can have those variant columns within a Parquet file. And then at the same time, they could actually be manifested in what's called a shredded column. So then again, it's actually stored as a proper Parquet column. So I realize that's confusing, but so there's this long tail of like all kinds of capabilities, and I don't see them stopping adding this new stuff. And this, it's not like, okay, let me implement this thing and then I'm done. No, it's an ongoing thing. And I think this was definitely something which I didn't expect to that extent initially.
Yeah, awesome. Well, my guest today has been Gunnar Morling. Gunnar, thanks for being a part of the Confluent Developer Podcast.
Tim, thanks so much for having me. This was great fun as always. Thank you.